Welcome back to the 22nd episode of Creating Swish. So last week we finished up right here, and so another good progress this week. We implemented lazy sequences. We have transducers, regular expression literals, all these clojure string functions: join, split, trim, triml, trimr, trim new line, uppercase, lowercase, starts with, ends with, includes, blank, and replace. The subs function, the set function, and in the clojure.set namespace we have union, intersection, disjoin, difference, subset, and superset. And we added some IO stuff: slurp, spit, read string, and with open. And we got the symbol function vec, assert, close. Got a reader question mark, writer question mark, line sequence, and we have a new namespace, clojure swift.io, with reader and writer types. We've got dynamic vars, we've got the star out star dynamic var, we've got the binding special form, and then we have the PR string, PR, and PRN printing functions. So at this point we're all ready. The next step is to do the jank clojure test suite. Let's take a look at core here. So we've got string, all the others are built in, string join and set. We've got these in now, and core continues to grow. You see we've got the 4 macro. So I've created a demo that shows off all the functionality that we have. So the next step is for me to try and figure out how to get the jank clojure test suite to work. And this happens to be Apple's Worldwide Development Conference this week, so I may or may not skip a week, being distracted by that. But anyway, let's demo this. So here's the source. I'll run it later. We require everything. We've got printing on. There's we're demonstrating the union function. So everything that in this demo, it prints what we're going to do and then prints the result. So we've got showing off union, intersection, difference, subset, superset, disjoint, all the string functions. We got the lazy sequence functions that we're showing off here, with range, take, repeat, take, cycle. You remember we have atoms, but they don't have the compare and set functionality yet. Got the lazy cat functions. We got transducers that we show off here with all the different combinations thereof. We've got some core utilities. Excuse me. Some showing off some file IO by writing out to a file and then reading it back in. Same thing with some streaming IO. We use with open. We rebind byte to the writer that we open, and then we just print to it so it writes to that file. And then we read it back with the reader, using line sequence. And then we write one more line to that file and read it back. And then we delete that file, or at least empty it. And then we have dynamic vars that we show off, verbosity and multiplier for when we print. When we print out lazy sequences, the REPL will only print up to 1,000 elements, then it'll do ... unlike Clojure, which will just keep going until you do Control C. So we limit the printing there. And so let's run this. We can do Swift run Swish, and then it's demo 22, I believe. I'm gonna pipe this into more. All right, let's see what we got here. So here's our closure set. Union of 1, 2, and 3, and 2, 3, and 4 is 1, 2, 3, 4. We got the intersection, which shows 2, 2, and 3 is right. Difference is just 1. Is it a subset? Yes, it is. Is it a superset? Yes, it is. Disjoint. Take 2 and 3 out of that set. We get 1 left. Clojure string. Join A, B, and C. We get A with the separator of comma space. We get A, B, C. Split them up with a comma. Notice we're using a regular expression literal. We get the array ABC. We trim hello on both sides. We just trim the left. We just trim the right. Uppercase hello, lowercase hello. Does Clojure start with CL? It does. Does Clojure end with RE? It does. Does Clojure include OJU? It does. Is this string of spaces blank? It is. Is hi blank? No. Replace hello, the L in hello with R. We get hero. Replace this in this string all the digits with angle bracket N or bracket. We get that. Same thing, but replace it with by calling a function, which is one of the arguments of replace. Our function must be just for putting brackets around that number, what it matched. Lazy sequences. Take 5. Range of 5 gives 0 to 4. Range 0 to 10 was set by 2. Take 5, iterate by inc of 0. Take 5, iterating a function of take 4 by repeating XX or the keyword X all the time. Repeat the keyword Y 3 times. Take cycle 1, 2, 3 repeatedly. Take 6 of those. Repeatedly inc. Take 4 of those. Lazy cat puts those together. And then we have transducers. Map inc to this sequence and add them up. Filter even, transduce with a filter even with a conj. I haven't used transducers a lot, so I barely understand how they work. But this is how they're working. Take 5 from range of 100 and put that into an array. Get the distinct sequence of 1, 1, 2, 3, 4, which is 1, 2, 3, 4. Get the dedupe sequence, 1, 2, 3, 1. Get partition range of 8, partition them all into 3s, give you the sequence. Gives you 0, 1, 2, 3, 4, 5, 6, 7. Interpose the symbol set between 1, 2, and 3. Take the sequence, take the nth, take the second element from the range of 8. Every second element, 1, 0, 2, 3, 4, 6. Do a sequence called keep odd on each element, and keep odd will return true or false, so we get a list of true, false, true, false, true. Now we get a sequence with map index, which gives you the index and the element. We call vector on that, so we get, and then we call that on the vector of these symbols, and also of the second vector, which is 2 and the keyword C, and it puts the index with each element. Into, got this function. I don't know what that does. A lot of going on there. We're composing the function filter odd with mmap inc. Passing it on that. I'm not even sure what deduction was. I forget what that does. And we put that in an array. We get 246. Core utilities. We got the vec. Given a sequence, it returns a vector. The vector of nil is empty. We read string 42. We get the 42 number. Read string of a list. We get the list. Assert that the vector of 1, 2 is the vec of 1, 2 is 1, 2. That those are equal. Yep. Assert's working. File IO. We spit 3 lines into this file. We append a 4 line. We slurp it back. Then we write 3 lines out to a different file, I believe, with the binding bound. And we append a 4th line, and then we do a line sequence on those, and we get out what we wrote. And then we have dynamic vars. We change the var verbosity to 1. Then we rebind it and print it out. See, it's rebound there, and then it's restored. Nested bindings, things like that. So that's the demo. Let's show the print limit. So if I just say range, you'll see it ends right there at 9999. And if I remember the print limit, you can change that. It is a dynamic var, if you can find it. All right, that's not it, but anyway, you can change that if you want. And so that's where we are. So next is, like I said, is to get the Jank Clojures test suite working. I don't know how hard that is going to be. I doubt we'll pass it. We'll have to probably make some fixes and put in some missing stuff and all kinds of things to make that work. So that will be interesting. And then on our roadmap, well, once we get that to work, then we'll go from there. But that's where we're at. So it's coming along nicely. So I hope you like that. Again, please comment. Let me know what you'd like to see. And if you'd like to support my work, buy me a coffee. Links below, and the repos below as well. Till next time.